Good day to all of you. I am Dr. Arvind Sharma, Associate Professor in Physics, Government Dugar College, BIKANER. Today's topic for M.SC final students is klystron working and operation. Today we are continued last lecture, but today we are trying to understand in a large view klystron's working and operation, so you can easily reply your long answer for two cavity klystron working. This is a well-labeled diagram. Every part is clearly shown here. First part is cathode and some voltage is applied here. So electron beam emitted from cathode, that voltage is known as VC or V cathode. Second one, voltage is applied between anode and grid, that is known as VG, and this voltage is applied between cathode and cavity, so it accelerates or it gives high acceleration to the electrons. So there are three voltages. We can easily understand the first part. Electrons are emitted from the cathode as usual and focused by first grid. Emitted from the cathode and focusing is done by the grid, which is operated at low positive voltage. That means VC is greater than VC. This grid also controls the electrons in the beam also. Electron numbers are also controlled by this grid. A high positive voltage. High positive voltage applied to the cavity resonators. High positive voltage applied to the cavity resonators relative to the cathode. With respect to cathode, a high positive voltage is applied, gives the electrons a high velocity. High velocity attained by the electrons at the entrance of the first cavity resonator or buncher cavity, first cavity, input cavity or buncher cavity. Here voltage is V0 greater than V cathode greater than VC. Okay. After that you can easily see here, this is the buncher cavity or input cavity. Okay, where RF input or microwave input is given through coupling, and this space is known as field free drift space, where bunched electron beam or density of electrons happens due to velocity modulation. This is output cavity or catcher cavity, and this is also provides output microwave or RF as a coding input, and this is collector which collects the electrons, and this part is given spacing between the different parts. Suppose that this is at 0, this position is at D, and this position is L plus D, and this is L plus 2 at different times, T0, T1 and T3 corresponding time is also given. And this curve shown the density of electrons. Electron beam is drift space and density of electrons is maximum here, where velocity modulation happens. Electrons are emitted, accelerated, so with high velocity they enters in the buncher cavity, and after that they crosses in this space. Bunching of electrons or velocity modulation happens in field free drift space. After that it crosses the catcher cavity and collected by the collector. So Here you can also use feedback cable if it operates, if you want to operate it as an oscillator. So this is the diagram for your 2 cavity klystron amplifier. Now what happens after that that it enters the buncher cavity? First of all, shape of the input resonator. What is the shape of the input resonator? Is such that electron can pass through. Electron can pass through. Okay. Shape can be designed like that. In a time short in comparison with the period. What is the period of the electrons? In comparison to that, short time, within short time, it enters the electrons at a point where electric field is parallel. At a point where electric field is parallel. When electric field is parallel to the direction of the motion of the electrons, as hen what that position is at antinode. When electrons are at antinode, then they can pass through the input region. The structure of the grids. What is the structure of the grids? Is such as to enable electrons to enter and leave the cavity. Grids structure should be like that electrons can easily enter and easily leave the cavity, but to confine the electron, but what is necessary, confinement of the electromagnetic field is essential inside the cavity. Confinement of the electromagnetic field must be necessary. Okay. Electrons that pass through the input resonator gap during the half of the cycle, in which the alternating field accelerates the speed of the electrons, and those passing through during the half in which alternating field retards them and are slowed down. Okay, which are accelerated if the electrons entering, when they are accelerating, then their speed is increasing, and if electrons or alternating field retards, then their velocity is slow down or decreases. In the field drift space beyond the exit grid, after exit grid there is a space that is known as field drift space. There is no field. The faster electrons overtake the slower ones that left the gap earlier. Faster electrons overtake the slower ones that left the gap earlier because their speeds are high, and the action is such that some distances beyond the resonator, large number of electrons will be arrived periodically during a very small intervals. If faster electrons crosses the slower electrons, then somewhere there becomes bunchage of the electrons, and this is known as bunching of electrons, and this happens because of velocity modulation. A second cavity resonator, called is also output cavity, is located near the point where the bunching is greatest. The position of second cavity or output cavity is adjusted where bunching is greatest. Okay, bunching is greatest at the middle of the output cavity. The output resonator is tuned to the same frequency. There should be tuning of the output resonator and input resonator. That means bunching cavity, input cavity and output cavity should be tuned. This is the essential condition for or requirement for 2 cavity klystron. If an alternating field exists in the output resonator gap and the bunchage of electrons pass through it at a time in the cycle at which alternating field has retarding values. Suppose electrons are entering and at that time alternating field is retarding value. Okay, then the electrons are slowed down by the field and deliver energy to the resonator. At that case, if electrons are entering when alternating field has retarding value, then electrons deliver the energy to the resonator. The energy delivered is maximum when it is maximum if the electric field during the transit of the electron bunches is just sufficient to bring the electrons to rest at the farther side of the output gap. Energy is maximum when electrons are at rest at the farther side of the output. Then its total kinetic energy is delivered to the resonator. Actually, the retarding field in the output resonator need not to be produced by excitation from external source. It is not necessary that retarding field is necessary from external source, since a bunch of electrons is passing through the resonator. If bunches of electrons passing through the resonator, they induces charge on the opposite grids. When bunches of electrons passing through the opposite grids, then between the grids or between the gap or grid gaps, what happens? Induces charge in opposite grids of the gap, and that sets the currents in the resonator. Because of the oscillation amplitude of the output resonator, can build up only if electrons deliver energy to the resonator. The oscillation builds up in the proper phase. Oscillations are also in proper phase to retard the electron bunches. The two-cavity klystron can be used as an amplifier also by feeding the input signal to the input resonator, taking the some output part from the output resonator. If some of the power delivered to the output resonator, its feedback to the input resonator in the proper phase. It should be like an in proper phase. Okay, it can supply the alternating current field required to modulate the velocity of the electron streams. It can supply the alternating field which is required for velocity modulation for the electron beams. When the power delivered to the output resonator, suppose power delivered at that time, electrons equals or exceeds the losses in that resonator. Okay, when power delivered, electrons equals or exceeds the losses in that resonators, and in circuits coupled to the sustained oscillations can take place. The initial alternating fields are required to start oscillations are supplied. Initially, alternating fields are required to start the oscillation as usual in feedback oscillators. Fluctuations of the electron beam current and noise voltages also happens. Since the two resonators are at same direct potential, two resonators are at same or equal direct potential, electrons that strike the farther wall. Suppose electrons which are striking the farther wall of the output cavity are returned to the cathode. They return to the cathode through the source of accelerated voltage. This is the problem, and to overcome this problem, secondary emission resulting from the impact of electrons. What happens? This is a problem, and from this arises secondary emission. And what happens? Impact of electrons that reach the farther wall with appreciable velocity. The electrons are usually allowed to pass the grid in the further wall into a collecting chamber. Okay, to overcome, there is a collecting chamber and collector collects the electrons. An alternating method of collecting electrons that are not brought to rest in the output, suppose electrons are not at rest, is by means of positive collector. We can give the positive voltage to the collector and it collects the electrons. Figure 1c that shows the essential structure of disc seal klystron can be used with demountable coaxial line of effect. In a klystron in which cavities are integral part of the tube, each cavity is usually tuned by changing the separation of the two plates of the cavity. Klystrons in which cavities are integral part. Because cavities are integral part, each cavity is tuned by changing the. How you can tune the cavities? By changing the separation of the two grids of the cavity, and thus the lumped capacitance across the high voltage point of the cavity. And if you changes the separation of the cavity, and what happens? Lumped capacitance across the high voltage point of the cavity. In two cavity klystrons, the two cavities must tune simultaneously. Both cavities should tune simultaneously. Difficulties involved in tuning two cavities to resonance and in maintaining proper tracking over a range of frequencies are avoided in single cavity oscillator. Klystron in which the velocity modulation and energy extraction are performed in the same gap. Klystron in which velocity modulation and energy extraction are performed in the same gap. In the same gap, velocity modulation and energy extraction happens. The characteristics of two cavity klystron. What are the main basic characteristics? Efficiency about 40%. Power output, average power is up to 500 kilowatt and pulse power is up to 30 MW to at 10 gigahertz megawatt. Power gain is about 30 dB decibel. These are the maximum achievable performance of two cavity klystron. And at last, we need these assumptions for klystron also. Here in the whole theory, some assumptions are necessary, and due to these assumptions, some restrictions or some limitations of klystron is also. So you put this part at the beginning of your answer. This para you shift at the starting of your answer. First of all, put this para, and after that start from the lecture. Okay, if you answer your long question. Electron's beam is assumed to have a uniform density in the cross section of the beam. Electron's beam's density should be uniform in the cross section of the beam. Space charge effects are negligible. We are assuming the space charge effects are negligible. The magnitude of the microwave signal input is assumed. What is the magnitude of microwave signal? We assume that this is much smaller than the DC accelerating voltage. From the DC accelerating voltage, microwave signal is assumed much smaller. The alternating voltage between buncher grids is assumed to be smaller in comparison with DC accelerating voltage. The same thing is in other words shown or given here. The electrons transit angles. Electrons transit angle through the buncher and catcher grids are assumed to be negligible. Electrons transit angles through the buncher and catcher grids are assumed to be negligible. And number 5, all the electrons which leave the cathode are assumed to pass through the catching plate. Suppose electrons are leaving the cathode, and we assume that all electrons passes the catcher plate. So today we are trying to understand, or we are trying to develop our concepts for 2 kVt klystron working and its operation, and you can easily apply you can reply your long answer, short answer in any kind of question about this part. In next lecture we try to understand about its other working, like as velocity modulation. Okay, thanks to all of you.